Hello class, this is the video to explain more about the team project. I received lots of questions and most of this question back to not reading the instruction. Please review the instruction carefully. In the instruction I explain everything you need to perform that analysis. Also, please remember this is week 4. And I do expect all of you to be familiar with our studio. And now we are submitting, most of the class are submitting week 4 exercise. So basically, this is not a good reason. I don't like to say excuse, but this is really not good to see some of you are still not getting familiar. I don't expect it to write a code professionally, but I do expect it to know at least our studio and be able to work with that. Okay, this is the instruction. In the instruction, I explain a step-by-step guideline to get this done. First of all, you need to find your data sets. In the class, you can go to week 6. The list of dataset is there. This is all the dataset you need to get. 1 to Minnesota data, Medicare data, imaging processes, dental, and MEPS data. By default, you looked at that before because you already submitted your topic. Also, I converted some of this data based on the topic selected by most of the class and put it in week 4. This is week 4 and this is the data sets here. This is the codes, this is the data sets, and to be honest, there is not a significant differences between master code. So with one master code you are able to do all the analysis for any type of data set, include in the class or exclude from the class. The only things you need to do is to change the name of variables and the data set. So for now I'm looking at the one of the master code. Let me go and open the master code for example for Medicare data. This is the Medicare data master code, and first of all you need to read the data sets. The basic is that you can generate a sync command here and to keep their log in this file. Make sure when you open the sync command, close it at the end, otherwise you are not able to see any output in a console. Or do not run the sync command, and you know how to silence the command, correct? You can just put a pound sign in the first line before starting the code, and that command will be silence. Okay, now I have this data, Medicare national data by county. Let me go back to the class. This is Medicare national data by county. If I open this data set, it's slightly different with the data that you have in the class. The difference is the CSV file. So basically, if you open the class data, let me go to week 6. Here, Medicare national data by county. This is the data set, and then okay, still working on this. Okay, here in this data set you have 2 rows for the as a name of variables. So if you use this in Excel in the RStudio, so it's really hard to to find the name of variables. Basically all of these three variables will have one name, and it's not easy to find the variables. It is possible, but it's not easy. Okay, so I do suggest you to just select the name of variable, select the variable you like from your dataset, or just use the CSV file and then run the codes. So this is the CSV file I'm running here. Okay, for this specific codes, I'm going to compare the percentage of lipids in Maryland and Virginia. So for that reason, first of all, I'm looking at the name of variables. Name is data. Okay, you can see all type of the variables here. So, and this comment generates a data set and call it Virginia, Maryland. So this is, you can rename the name of your data set using only this command, the name of the new data, and this is the data you have from here. Then I just use the subset data and exclude Maryland, include Maryland only and Virginia only. This piece of code may be not useful for you, but it's good to know. Then I like to see the mean. This is the one line code to just see the mean for any variables. If I go with mean, so I can see mean, Maryland, the name of data, and percent of lipid. So usually I do recommend to add this line as well, because if you have some kind of missing observation, you will not able to see any result. And then the mean for Virginia and standard deviation. And then I like to see the number of observation. I look at this. This is 24. This is 137, 34, and I need to go with a t-test. This is one line code, the name of data sets, and then t.test bracket, first data set, second data set, and that's it. And the result should be the Welch sample t-test, and for Welch sample t-test you just need to look at the p-value. Any p-value more than 0.05 is not significant. So we can also look at the plots, boxplot here. You can see there's basically there's no significant difference here. The range move between 65 to 90%, so I do not consider these three observations as outliers. So I'm going to keep them in the model. You can change the title over here, for example, comparing lipid percent of Medicare with percent of lipid. Let's say percent of lipid overall. Copy this. This is the text. You can write everything you like here. In Maryland and Virginia, right? So I need to run the code again, and this is it. You can also look at the density plot. Look at this. The density plot is a good plot to show you how the data distributed. As you see here, the blue line is Virginia and the red line is Maryland. So as you can see, probably that is slightly different. In Maryland we expected to see higher. Most of them is 75 to 90. And if you look at the mean over here, the mean was here. This is the mean, Maryland 83, 82. This three item is because of the outlier in the Virginia. So if you look at the box plot over here, you can click on this, see the previous plot, and then go back to the table. This is the table you have. You just need to report the name of variables here. Let me copy this in a separate document. Okay, for this specific file, this as analysis, I have these variables: percent of lipid overall. I'm gonna copy this here. Definition is gonna be percent of Medicare beneficiary with percent of lipids, blood lipids, and Medicare beneficiary. The data, okay. The data description of codes is a numeric code source Medicare national data by county and year 2013. The other variable is the state, that's the Maryland and Virginia. This variable is a categorical variable, and the Medicare and Medicaid, that's it, and we don't need any more variables. This is it. Also make sure to add a title for the table 1. Okay, definition of variables used in the analysis. You could have similar table here to report the mean and the standard deviation. So we don't need this one. The name of variable is percent of lipid in Maryland, percent of lipid in Virginia, and if you look at this file, we have the percent is 83. I can copy this here. In Virginia is this, and I also need to report the standard deviation. You could add one more column and just report the p-value. The p-value is here. We don't need to for both variable. The value of the p is this one is okay. This one, okay, and you don't need to report all of them. You can just report two variable, and you say to round this, it's gonna be this one, and but keep the all four decimal for p-value. Okay, we can change all the fonts to Times New Romans, some 11, so I'm gonna keep them all, and that's it. This is the table. Descriptive analysis to compare percent of Medicare beneficiary blood lipid in Medicare beneficiary, Maryland and Virginia 2013, because the data is for 2013. Then you only need to just report to figure, and you can just copy, right? Copy image and paste here. You can press Ctrl V to paste. I can also copy the other variables here, export, save as the image, or you can just click on this, copy on the copy plot, and then you can paste here. So you have all the analysis you need. You just need to write a short discussion to compare this between these two states. This is why I expected to see what I expected to see for the team project. I'm gonna go with one more example to just explain 2 times. I always recommend you to just save the file, so I'm gonna save as here as a different file, because I already shared with someone else, so I like to keep it the first one untouched. Okay. I'm gonna go with one of the Minnesota data here, Minnesota hospital. This is the data set I have. In this data set, someone like to compare the obstetrics admission with neurology admission, and this is the data set. Again, here you can silence the code, the sync command, and then let's see this data, Minnesota Health Report data. Dropbox, Minnesota hospital revisit, hospital, correct? Hospital report CSV, yes. The hospital report CSV is this file. I just converted that file from the class. This is the file. In the class you have this file, Minnesota hospital report data. I believe this is this data set. Let's see. Yes, I believe that's this file. No, it's still working. Let's see. Okay. Data license bed. Okay, which of them? Okay. Yes, that's it. This is the CSV file, and as you can see here, the differences is the first line. Probably you can even use this, but you can just change it in the CSV file, and you know how to convert the file to the CSV file. Just click over here, save as the file, browse, and in some place, for example, I don't know, in any place you like, for example, I'm gonna go with UMUC and add a name you like, and then change the format here to the CSV comma delimited, and then save it. I'm gonna save it as a test, and it's gonna ask me some question. You have to approve that. I also do suggest that if there's something like this, all of them is for the RStudio. RStudio consider all of this is it is space as a dot, so you can change the name of variable you like just with a simple name here, and then save as a file, CSV file. This is in brackets. Okay, I don't need this file because I already have this file here. I believe I shared in the class. You can go with that. If you have any other question regarding to the format of the file, do not hesitate to ask me or your instructor. Okay, so let's run this file and see the data. First of all, I need to see, you know, if you are working with a package already, with the exercise already you install the deploy package, you don't need to install again. This is fine if you want to install, but I don't recommend because it's a time consuming sometimes. So you can just load it. See the name of variables. Here are the name of variables. I like to compare the obstetric admission with neurology admission. I'm looking for that. Neurology admission is here. Neurology charge. Where is the obstetric admission? Okay. Obstetric admission is here. I just need to copy exactly like this. I already copied here and here. 2 options here. You can go with a summary and see the means here. This is the means, but the summary didn't give you the standard deviation, right? You can see the summary here. The means is here, and easily you can just copy this Control C, Control V, and pay and see the standard deviation, right? Just change it to a standard deviation and you will see the standard deviation. Easy, right? The standard deviation. Or you can go with the second command, or just go with and change the standard deviation to the mean. And this is the mean, and this is it. You can see the standard deviation, the means. That's the same. This is exactly the same as reported here in the summary command. You can use my table command to see the numbers observation, right? This observation for this 104, 128, and okay. And this is a t-test. You can compare this, and this is the box plot. Yeah, there is outliers here, but this is fine. You can just keep this, or you can just eliminate the data using the I will explain later. So this is the density plot with the real data. So if you look at this, there is kind of outliers here. We can go back and look at the box plot. Some of them is I can consider maybe more than 3000 is outliers, but to make sure I just eliminated all of them here. In this comment, I joined a new comment, a new data set, called it new data, eliminated any observation more than 2000, and then looking at the box plot here, correct? This is the box plot. Okay, I eliminated them. Something has happened here. Okay, this is it. It's running. And then I'm going to look at the density plots here. Okay, it's more likely to be more normalized than the other density plots. Let me go back to these tables. Whatever you need to report here. Okay, this is different. Okay, this is the table. I forgot to add number of observation here. Okay. Report on the insert in the left. Okay, I need to see the observation, right? Observation here is for the Medicare data. I need to go back and look at this other codes. I already have, this was the Medicare data, correct? Let me go back and just add from my table here. I had 24 for Maryland and 134. 24 here, 134 here. Okay, what about the Minnesota data? I'm gonna go and report this here one time for you. This is definition. Which variables did you use here? This is the variables I have here, right? This is Minnesota. I have two variables. First variable is number of admission for obstetric, and I have number of admission for neurology, right? This is it. This is the name of variables. Definition is number of admission for obstetric. Okay. And this is number of admissions for neurology, right? So both of them is numeric variables, Minnesota data, right? And you can see the data set here. I believe it's in the class. There is a note here, and if you look at the note, this is the data set. Yes, this is data set. This is data for Medicare. So anyhow, I'm not looking for this for Medicare. The data set is a Medicare 2012. I don't need that. I need the data for Minnesota. And this is not the CSV file. I have to download again to see. But you can look at the note and see the data set, or just you can just, because I know you don't, if you don't know, look at the class. I know this is the Minnesota data, Minnesota hospital data. the year, it's a 2012, 30 data, and the name of variable here, the same variables. You can just copy here. Report observation. Let's go back and go step by step to the Minnesota data. This is the Minnesota data, correct? I'm running again. I'm reading the data sets and looking at the summary. The summary give me the mean. I can copy this, or you can go with this command. I just need to copy this means. It's for admission for obstetric. And then this is the admission for neurology. Okay, and then with standard deviation, I need to report the standard deviation also. This is it. And then this is for this. Okay, you can just copy using Ctrl+C and Ctrl+V to paste. You also need, or you can just easily click and right copy or copy here. So the other things, I need to see the number of observation. I see 104 here and 128 here for the neurology. Okay, 104 and 128, correct? Let's make sure 120. Okay, then I need to go with the t-test. The t-test is significant here. Even if you run the t-test, you can find the mean. So basically with the only t-test you can find the p-value and means, and then you can go with the standard deviation and my table command to find the standard deviation. Okay, anyhow, but I do suggest you go with step-by-step guideline to make sure you are not confuse yourself. Table 2, correct? This is table 2. Then the next step is just go ahead and just copy the plots. I have 4 plots here. The plot is okay, figure 1. Yeah, again here at the title it's gonna be comparing admissions between, I'm gonna go with the short name, obstetric and neurology. And neurology. Okay, and I'm gonna run this again and see. Sometimes if you have a long title, you can give more space to this, right? And then you copy this. So anyhow, but for me this is okay. Okay, click copy to clipboard, copy here, go back to file and then paste it here. Make sure to round this. 2 decimal is enough for this, and this is 8. Same here, same here. Okay, I have 4 figures, correct? So I'm gonna go with all the figures I have. This is the density plot, figure number 2. Actually, this figure number 1, this is figure number 2. You can change them, right? You can just change them here between obstetric and neurology admissions. And then here, you can remove them here. Run this. Okay. You know, this is you can change the region location using this. This is top left. You can say top right. It's gonna be go to the other side. Also the label is incorrect, the red and blue. The B is here. The B is the first variable here is the obstetric. and the second is second variable here, no logic, right? You can write any name you like, but as long as the code is between code, it's considered as a text. So if I run again, you see it moved to the right. You have to okay, and the legend is this. Okay, so this is the real data, correct? I'm gonna add, say, real data here, and I'm gonna run this again. Okay, this is real data, and the real data is capital R. Okay, then I can copy this here to this, copy to clipboard. This is here. So if you like to report after eliminating, you are okay, do that. This is okay to just report, or just look at that. You know how to change the name of variables. You can just copy the name from here and to here, right? So figure 1, okay, this is here. It's gonna be figure 3. Okay, outliers eliminated, and then you can run this, and this is it, figure 3. I'm gonna give more space to this to have a nice figure, and copy to the clipboard, copy, and this is it. This is figure 3, and the last one is a figure 4. This is exactly the same figure, right? So because I changed them a little bit, I'm gonna copy them here. Oh no, so I have to change all of them. That's okay. I just need to change the name to the figure 4. Top right. I already fixed that here. Top right. Okay. That's it. This is the final figure for this. Copy to clipboard, copy, and then paste here. This is it, and you are okay to just need to describe these findings here. For example, there is a significant difference between number of admission between obstetrics and neurology, with higher admission for obstetrics, 688 compared to 255. And this is significant. If we go back with the Medicare data, I'm gonna say I have a comparison here, 83.2 in for the Maryland, 82.69 for Virginia, and this p-value is not significant, so I can say there is no significant differences between percent of Medicare beneficiary who had lipid for blood pressure, blood lipids in 2013, and then you can support your finding with a short discussion. This is okay. Let me save it. Always make sure to save your file because I modified it a little bit. I'm gonna save it here. You can use these master codes for any data. Okay, for any data set. The only thing you need to change is this data set here, this one, and the variable's name. These are the place you need to change. So if you're using maps data, make sure to have your file in CSV format, and then look at the name of variables, pick up the variable you like, and then use this command. Change this or summary or means, standard deviation. The only thing you need to change the name of variables, and the easy way to do that is to just copy the code in a Word document and exactly change the name by this one. You can just copy exact the name here, use the find and replace, all the code change. And but to learn, go ahead and do it step by step by yourself in our studio, because it's if there's no outlier, there's not more than 8 lines of code, and I believe it's very easy to follow that. Okay, class, thank you for listening to this or watching this. Please let me know if you have any question, and stay safe, and thank you, and have a good day. Goodbye.